So in the previous class, I think we're completely done with the supervised machine learning. Okay, so let us start, guys. In the today's class, we will be discussing something about. So we are starting a new thing that is like a unsupervised machine learning, guys. Okay, unsupervised machine learning. So it is one of the best algorithms only, guys. Okay, I'm going to discuss some of the good algorithms in the unsupervised machine learning. But scope is, if you can able to see the scope means the importance we can able to understand from the unsupervised machine learning means along with after unsupervised machine learning, there is something like a semi-supervised machine learning also. Okay, so what is the advantage of this thing, sir? Even though we are having the supervised machine learning algorithms, okay, so even though we are having the what is the supervised machine learning algorithms, so those can able to solve any kind of problem, any kind of project. If you can able to see in the previous class, up to previous class, we have discussed something about the ensemble techniques, which are very powerful and so easy techniques to apply. Okay, so we can able to solve any kind of project with the help of ensemble techniques, right? So even though after having the what is that supervised machine learning good algorithm, again why we are implementing, why we are adopting the unsupervised machine learning techniques, we can say. Okay, any idea on this thing, guys? Any idea? An idea on Andy? Srikanth, Saideep, Divya?
No, sir.
Yes,
No,
sir.
not. Yeah, please. What is the thing, Divya?
So unsupervised algorithm వచ్చేసి without label data, sir. Only input features ఉంటాయి.
Hmm.
సో సో ప్యాటర్న్స్ అవన్నీ సెల్ఫ్ గా ఫైండ్ అవుట్ చేసుకుంటుంది.
Patterns, huh?
Yes, sir.
Supervised machine learning patterns है కదా?
కానీ అక్కడ అవుట్పుట్ ఫీచర్స్ కూడా ఉంటాయి కదా సార్.
Okay, okay, you are saying that. So in the unsupervised machine learning, we don't have the specific output. You are saying that.
ఎస్
Yeah.
సార్.
Point. Good point. Very good point. So other than this thing, anything is there? Other than this, anything is there, guys? Yeah. In addition to this point, guys, it is what is the Divya made? That point is okay, very correct. Okay, there is no doubt in that. So along with that, okay, point, what exactly I'm saying is, so in the supervised machine learning, guys, we required for the training any kind of algorithm, we require huge amount of data. Okay, so definitely, so we're having is input features are there, output features are there. So for training the any kind of algorithm, for getting the specific output, so we required what is that? We required the huge amount of data for the training. Okay, but in the advantage with the unsupervised machine learning is, so you can take, there is no need of that much huge amount of data. Okay, anta data అవసరం లేదండి. So for example, for the supervised machine learning, you need thousands of the data. Okay, that is that is the amount of data required for the supervised machine learning. But with respect to semi-supervised as unsupervised, we require hundreds of data is enough for us. Okay, we don't know, right? Sometimes in the while doing the projects in the real time, in the in the industries, we don't know. So we may not have the data on that time. Data ఉండకపోవచ్చు అక్కడ. So on that time, still without data also, you should be able to implement the project. So in that cases, guys, okay, we can use the unsupervised machine learning. So with the help of what is that little amount of the data, we can able to train the any kind of algorithm with respect to the semi-supervised and unsupervised. So we recently implemented the semi-supervised machine learning and one also like unsupervised machine learning algorithm. Okay, in our computer vision actually. Okay, so I will be discussing those things in the computer vision. Okay, we'll discuss in the deep learning also. Yeah, that is the importance of the unsupervised machine learning. Yeah, let us without any delay, let us go to the introductory part for the our unsupervised machine learning. Okay, so is that clear? Is everything is fine up to this point? Can I get the response from you?
Yes, sir.
Clear, right? Yeah, great. Okay, so let us go to the, let me open my notes I'm having. So unsupervised machine learning, guys. So with the help of supervised machine learning, we can able to solve the regression problem statement and a classification problem statement. Okay, so in the supervised machine learning, if you can take any kind of data set, we're having input feature f1, f2, f3, f4, and there is a output feature like a output feature will be there. So in simple way, so there are independent features are the dependent feature is there. Okay, so that is something about supervised machine learning. We have seen the so n number of good algorithms in the supervised machine learning techniques. So let us go for the unsupervised machine learning algorithms. Okay, like a techniques. Okay, so what is exactly unsupervised machine learning means? So simply, guys, we can able to do the clustering of these things. Like a clustering means grouping of our data to a similar cluster. Okay, so grouping of our data based on the similarity we can able to say that is something like a main aim of the unsupervised machine learning, something like a clustering the things. Okay, grouping the things. So the important point in the unsupervised machine learning is in the given data set. So for example, I'm having a age, experience, salary. Okay, so but it seems like we're having the age experience as the input feature and the salary is like output feature, but that is not the case in the unsupervised machine learning, guys. Okay, so even though looking like this kind of thing, but so it is a okay, we can take this example for the unsupervised machine learning. Okay, so for this particular data
Excuse
set,
me, sir.
please, yes, please,
Sir, can zoom చేయరా?
zoom channel. Sorry, is it fine now? Okay, now
Okay, sir.
okay now. So now what exactly I'm saying is, yeah, so this is a age, experience, salary is that this data set we can able to solve with the help of supervised machine learning also. There's no doubt in that thing. Okay, we have took this example so many times. Okay, so in the regression problem, but guys, so in the unsupervised machine learning, guys, there is no output feature will be there. There is no output column will be there in the what exactly in the unsupervised machine learning. Okay, so simply, so there is no output feature, everything is like input feature. So based on that one, we have to group the things, we have to cluster. For example, I'm taking the salary is there, so I can cluster the salary who are having, for example, so in the range of 10,000 to 20,000, I will be making one group. The range of the salary, so the salary of people, the ranging between the so 20,000 to 50,000, I can able to give one more group. So 50,000 to 1 lakh, 1 lakh to 2 lakh, like that. So I can take the range of salaries. I can able to group those particular people. Okay, so that is the understanding we can say, guys. Okay, so for example, if you can see in the marketing guys, so most of the people, okay, also high profile people will be there, so they will cluster the things and they will keep on calling to high profile people. So take these things, take those things, like that they can able to make it. Okay, so that is something like a we are grouping the things. Okay, guys, here given the example for finding out the cluster, I have given the one mean for you. Okay, like a range of the salary is like a one mean, but in the reality it may be different, guys. Okay, example first of all, so that is a simple example I given you, but in the reality, so it may be varies to the different project to project, okay, use case to use case. Okay, so that is a simple understanding of this thing. Okay, yeah, so you can take so cluster 1, cluster 2, cluster. So cluster 1 means I can take only in the cluster 1, I may have the people, the salary in the ranging between the 10,000 to 20,000. So in this cluster, the people, the salary is ranging between the, for example, 20,000 to 50,000. So in this case, 50,000 to 80,000, any kind of range we can take. So in this way, we will group the things, guys. Okay. For example, when the new data, for example, a new person is came. Okay, his salary is something. I can easily, for example, his salary ranging, but for example, his salary is something like 80,000. So I can able to he will be belong to the third cluster. Correct. So in that way, we can able to classify the things group the things easily, and also we can able to give the what exactly when the new data point, a test point, what is that we can okay, easily predict which group he belong to. Okay, that is a simple understanding of things. Okay, so customer segmentation is one other thing, guys. Okay, so one of the good example we can take. Okay, so data, salary, spending score is there. So new product discount. Okay, this is something different. Okay, this is fine. So you can take good example, something like so the people. 1 second, I will give you a very reasonable example for you. Okay, it will be very easy. Okay, I given this example in the previous class, I hope. Okay, for example, there are for example there are some players are there. For example, some cricket players are there here. Okay, some cricket players are there in the ground, actually I'm saying. Okay, so for example, one more players are there for a football players also. Okay, soccer players. Okay, in the same ground, soccer players also there. So, and again, there are some people are there. For example, you can take a so cricket players, so
Foot- Football players, sir.
football players, second, third ఏం చెప్పొచ్చు ఏమన్నా ఎగ్జాంపుల్ in games and outdoor games ఏముంటాయండి hockey players are there, hockey players.
Badminton.
Okay,
Badminton.
బ్యాడ్మింటన్ వదిలేండి, అది గ్రౌండ్ లో ఆడాలండి. సో ఓకే, సో అవుట్డోర్ లో ఆడేవాళ్ళు చూద్దాం ఫస్ట్. సో కెన్ యూ సీ నౌ I'm taking there are these three players are there. Three different sports players are there. Some people are belong to cricket, some players are belong to football, and some players are belong to hockey. Now, how can we do this thing? So simply, I can able to take this complete thing, guys. Okay. Now I can able to classify. For example, I will take a cricket players belong to this cluster. Okay, so I'm taking very bigger. So for example, I'm take a cricket player belong to this cluster. Okay, and something like a soccer players are belong to this cluster. And again, we can take so our hockey players are belong to this cluster. So guys, we made three groups here. On what basis we are making these groups? Based on the similarity of the points, we can say. For example, we cannot group the people who are playing both cricket and hockey, right? So we cannot group the people who are playing the cricket and football. We cannot do that one. So this is how we are making the group means on the base of similarity. Okay, I'm taking the cricket players. Cricket players means are similar, so that I can able to take this cluster. So I can take, for example, soccer players. All those are very similar. I can take this cluster. Like that, we can able to group the things. Okay, so based on similarity of the data only, we are going to make these points. Okay, similarity, I'm giving the very concrete term similarity, guys, but in that one so many things are there. I will be discussing in the upcoming classes, so some mathematical things will be there. Okay, that's fine. So now can you able to understand what I'm saying is ikkada అర్థమైందా అండి?
Yes, sir.
What exactly we are going to do in the upcoming classes?
Yes, sir.
Great. So now let us remind. Just go on mute if you are unable to. You're not speaking means okay. So now you can see unsupervised machine learning techniques are there. Okay, algorithm. So k-means cluster algorithm. K-means algorithm. So hierarchical clustering, DB scan clustering, Silhouette score, and PCA principal component analysis. Okay, so if you can able to see k-means algorithm, hierarchical clustering, DB scan, and PCA also one more algorithm, guys. PCA principal component analysis. Okay, I will tell you that is the first algorithm we're discussing in the next class. No, I mean in today's class only. Now, yeah. So these are the four algorithms I'm having. Okay, one is something like a k-means algorithm, hierarchical clustering, DB scan clustering, and PCA. So these are like algorithms. Now something like a Silhouette score is something is there, right? So it is like our validation metrics for the Silhouette score is like a validating the remaining this k-means algorithm, hierarchical clustering algorithm, so DB scan clustering, PCA. So to validate this algorithm, we will use the Silhouette scoring. Okay, for example, so in the supervised machine learning, we are having a confusion matrix, precision recall, so validation score. All these things are there, right? So those are like for the the metrics for the supervised machine learning algorithms. The same way for the unsupervised machine learning algorithm, Silhouette score is like a metrics for these algorithms. Understood what I'm saying is? Silhouette score is like a metrics for these unsupervised machine algorithms. అర్థమైందా అని చెప్పింది? Okay, clear? So these are the things, guys, we are going to discuss in the upcoming classes. So yeah, and guys, I'm telling you, so there is some caution I would like to give. So that is so these may include some mathematics, guys. For the maths include I untundandi, so please bear with me. Bhayapadoddu ippude. So I'm giving there will be some mathematics untundandi. So we will be discussing we will be going with the eigenvalues, eigenvectors, okay, and some other algebraic equations also we are going to we are going to solve. Okay, so please bear with me. Okay, so is that fine? Is everything is good, guys?
Yes, sir.
Everything is
Yes,
fine.
sir.
Clear,
Yes.
right?
Yes, sir.
Yes, sir.
Yes, sir.
Yes. Thank you very much. So now let us start with so our first. It is a very huge thing is there, guys. I don't know how can you able to understand. So almost 9 pages of mathematics is there. Okay, fine. Let us see. So let us see. Okay, 9 pages of maths is there. So it took too much time to understand. Okay, in the
సార్ కొంచెం స్లోగా పోయి అంత మ్యాథ్స్ ఉంటుంది
sorry, ఏమన్నారండి?
సార్ కొంచెం స్లోగా పోయి సార్ ఇంత మ్యాథ్స్ ఉంటుంది
స్లోగా చెప్పాలా?
ఎస్ సార్ అంటే ఇప్పుడు మీరు మ్యాథమెటిక్స్ ఉన్నాను కదా కొంచెం
మ్యాథమెటిక్స్ ఫాస్ట్ చెప్పచ్చు.
నెమ్మదిగా వెళ్తే మంచిది
ఓకే ఓకే, నో ఇష్యూ. ఓకే, మీరు భయపడకండి, సింప్లిఫై చేస్తాను ఇంకా. Yeah, principal component analysis, guys, PCA. Okay, say this is something like a dimensionality reduction algorithm. Okay, what exactly a dimensionality reduction algorithm, what is the purpose of dimensionality reduction means? Okay, we will discuss. So there is a particular term called, guys, a curse of dimensionality. Okay, so this is a very new term, guys, curse of dimensionality. Okay, what exactly we are going to do with this? What is exactly called as a curse of dimensionality? Okay, for example, I'm having a data set, guys, having the 500 features. Okay, 500 features. What exactly I'm trying to do? So data set having the 500 features, like a 500 columns unnayandi. Okay, can you able to understand, can you able to imagine that data set having the 500 columns in the data set, and we are going to train the algorithm, guys. Maybe can you able to tell me the what kind of algorithm will help us to so train the 500 features? Okay, so that is something like okay, this is a scenario we're having 500 features are there. Okay, so 500 features means what exactly we can say? Those are like 500 dimensions are there. Okay, we can say in other words, 500 columns unnayante we're having the 500 feature or 500 dimensions are there, correct? So now how exactly we are going to do with deal this kind of problem? 500 features ఉన్నాయంటే దీన్ని ఎలా చేయాలి first of all? So let us try to see the problem with all these things, guys. For example, I'm having a machine learning model. M1 is there, M2 is there, M3, M4, M5, M6 is there. Okay, so these are the, I'm taking the 6 algorithm. Okay, 6 algorithms to so do something. Let me tell you what exactly we are trying to do. So if you can able to see, guys, for example, in the first for the M1 algorithm, I'm giving the 3 features out of 500 features. I'm giving the 3 features to train the M1 algorithm, M1 model we can say. So from that one, I'm getting the accuracy, some accuracy. So for M2 model, from the M2 algorithm, I'm taking the 6 features. Okay, along with the output feature also we can take. Okay, so from that one, what exactly? So the 6 features, our M2 model or M2 algorithm will train on that 6 features, and it is going to give up some accuracy like that. In this case, I'm giving the 15 features. Okay, it is producing it is training on the 15 features and it is producing some accuracy. In this case, for the M4, I'm giving the 50 features to train. I'm giving some accuracy. I'm getting some accuracy. Like M5, I'm giving something like a 100 features. So for the M6, I'm giving the complete 500 features. Okay, so ilaga nenu ichukuntu vachanandi. Let us see what exactly happening here. ఇప్పుడు ఏమవుతుంది సార్, మీరు ఇచ్చి సో యూ హ్యావ్ గివెన్ ద సో different features for the different algorithm. Okay, so in the increasing manner, so what exactly happening here, what exactly we are observing here? Okay, so can you see for the 3 features I'm getting the for example, and okay, M1 model means we are training the M1 model, M1 or M1 algorithm with 3 features means I'm getting some accuracy here. So and again M2 with 6 features means I'm getting some accuracy definitely, guys. So in the M2 algorithm having a more scope to learn. Why? Because we are given the 6 features here. In the M1 algorithm we have given the 3 features only. So definitely the accuracy will be more for the 6 feature algorithm, this M2 algorithm. ఎందుకంటే So the learning scope is more, and it is going to produce the more accuracy compared with the M1 model. The same case. So same case in the M3 also. I have given the 15 features. Okay, and it trained the 15 features, and it produced some accuracy 3, and all definitely this accuracy also more than the this M2 accuracy and M1 accuracy. Why? Because so we have given the 15 features so to train the algorithm, and it is giving the, and the learning scope is more, and it is and producing the much better accuracy compared with M1 and M2. Okay, now for the M4, what exactly I am trying to do? I have given the 50 features directly. So 50 features ఇచ్చేసానండి complete గా. Now there is something different thing is going to happen, guys. Okay, so there is something happening. So M4, the accuracy is something going to drop. Why, sir? Why? What's the purpose of dropping the and ఎందుకు drop అవుతుందంటే? So guys, out of 50 features, we know that so corresponding to the output feature. So some features are very important, some features are not important. Okay, some features are useless for sometimes. Okay, so having the that means in the 50 features, some having a more correlation kind of thing will be there. Okay, so because of that heavy feeding up, overfeeding of the our features, our columns, our algorithm is going to drop. For M4 algorithm, the accuracy is going to drop. Okay, so నేను చెప్తాను దీనికి నేను జస్టిఫికేషన్ ఇస్తాను నీకు. So that is the way, that is because of the overfeeding of the our what is that our features. So algorithm is going to some it is going into in the stage of confusion, we can say. Okay, so అంటే మీకు అందులో ఇంపార్టెంట్ ఫీచర్స్ ఉంటాయి, which are some of the not important features, some are useless features maybe which are not contributing anything to the output feature. So because of that unnecessary, overfeeding of the our features. Okay, so our M4 algorithm may be dropping the accuracy maybe. So same thing for the M5 also. Now in this case I'm giving the 100 features. It is more worse than the M4 algorithm. So in the 50 features, again in the M6 500 features, it is more worse than the previous algorithms. Why? Because 500 features on ఏంటండి. Okay, so it is going to do something like a going to produce a very low accuracy compared with the other algorithms. Okay, ఇది అర్థమైందని చెప్పింది, అర్థమైందా మీకు ఇప్పుడు దాకా చెప్పింది? Okay, how exactly we are doing this? So
yes, sir.
That is exactly clear. Yes, sorry, ఏమన్నారండి? I'm very sorry, లేదు.
Clear, sir.
Clear, right? So that is exactly a curse of dimensionality. Can you see curse? You know meaning of curse? Curse అంటే తెలుసా అండి? Yeah, so yeah, it is like a kind of thing. Yeah, so because of the you're having a 500 feature, you're having enough data, but because of even though you're having a 500 features, so that 500 features are becoming curse for us, so to getting the very low accuracy. So can you see now? So that is the curse of dimensionality, having the high dimensionality like a what is that high dimensionality, like a number of we can say multiple, or I can say 500 features in the data set. So that is going to produce the very low accuracy. That is the curse of dimensionality. Okay, now I will give you one scenario here. Okay, so and also guys, most important, because of this thing, what exactly? So because of this thing, there is a performance issues will be there. So there will be model performance degradation. Okay, model performance degrade there is a performance degradation in the model, we can able to say. Okay, so that is a simple understanding, guys. So for example, let us take a real-time scenario now. So one person is there, guys. Person is there. So his domain expertise, we can say. So for this particular person, now what exactly we need is we want to buy one house. Okay, we want to buy one house. So we opened our requirements now. Okay, we have opened our requirements. So first requirement is we given that location. Okay, for example, location, we can take first feature or feature one, or our requirement we can able to say location. So location and average 2 BHK house we would like to buy. So now this person is domain expert, person is saying that so the cost will be in the range of 450k to 500k. Okay, he is saying that. Now in addition to the location, I need 3 BHK flat now, 3 BHK house now. So again, the person assumed something, calculated something. Okay, he wants 3 BHK in this location. That means so the cost will be increasing, right? So that means he is saying that the cost will be 500K to 600K. And again, so now one more requirement is, so I need a house beside a beach. Like I need a location, I mean view of the beach. Okay, so that again this person is calculated something. Okay, he need the 3 BHK house in this location that should be beside of beach, means again cost will be increased. Okay, so that is the one thing. And again my requirement, after along with this requirement, I'm adding one more requirement is, so I need what is that, I need my house should be like a very near to celebrity house. Okay, let us take any kind of so celebrity like a Samantha house, for example, let us take. Okay, so I need a house which is near to the Samantha house, we can take. Again, definitely there will be increment in the, okay, what exactly our cost of the house, correct? So can you see now, again there is something like I should have the house, so we should be like a 3 BHK in this location, it should be having the beach view and near to celebrity house. And again should be, and again the house a grocery shop should be there beside that house. Okay, these may create much impact, guys, but having the grocery shop around the house, this may create a low impact. And also beside of my house there should be a school also. So like that, can you see, guys? So if you keep on adding the requirements, this person is going to confuse a lot, definitely. He don't know how to calculate, right? Because we keep on adding the features. So can you see, you told location 3 BHK flat, beach view, so near to celebrity house, okay, grocery shop, school, and again you can add something like a, so there should be a cinema theater beside should be beside of my house. Like if you keep on adding this kind of features, definitely the domain expert is going to confuse. Okay, so there is you can say from this person, so his efficiency or accuracy may drop here. అంతే కదండి, ఎంత కన్ఫ్యూజ్ అయిపోతామండి ఇక్కడ మనం. Can you able to understand what I'm saying is? Can you able to understand what I'm saying is?
Yes, sir.
Everybody? Yeah, that is the curse, we can say. That is the curse. So we keep on adding the number of features means, so our person is, our domain expert is going to confuse same way our algorithm is also going to confuse. Okay, so from that one there will be a drop in the accuracy. Okay, so that is okay, curse of the dimensionality, guys. Okay, so we should do the something like a, what is the remedy for this thing, guys? We should reduce the dimensions, correct? అంతే కదా మనం చేయాల్సింది, ఇక్కడ ఏం చేయగలుగుతామండి? So we should, even though you're having a 500 features or 1000 features, so we should take the relevant features, okay, which are contributing to the output feature. Okay, that is the understanding of these things. So I hope you're getting the things. Okay, now sir, tell me, sir, how can we solve this thing? Within ఎలా solve it, sir? So two different ways to, okay, remove the curse of dimensionality. That means what is that, over dimensions, we can say. Okay, one is like a feature selection and one is like a dimensional reduction. So we know feature selection already in the previous classes. చెప్పండి మనం ఏ టెక్నిక్స్ యూజ్ చేస్తామండి ఫీచర్ సెలెక్షన్ కోసం? కెన్ టెల్ మీ సమ్ ఆఫ్ ది ఎగ్జాంపుల్స్, సమ్ టెక్నిక్స్ for the feature selection? What are the techniques we have used in the previous classes? बोलो. చెప్పకపోతే నీ క్లాస్ చెప్పండి. దివ్య, ఏమైందండి, మాట్లాడండి. శ్రీకాంత్,
One of the techniques is correlation, sir.
what is that?
By finding the correlation also, we can find the
Okay, correlation.
feature selection.
Yes, correlation, fine. Okay, so yeah, correlation is another technique we can able to find out. Okay, so covariance technique is there, correlation technique is there, right? And again, what exactly we can able to use? Can we take anything like a for the regression point of view? Anything is there? Okay, you can think. మీరు చెప్ప ఆన్సర్ చేయాలండి ఫాస్ట్గా. So there are two different ways to remove the cursor dimensionality, like a feature selection and dimensional reduction we can take. So implant features we can able to select from this thing, and dimensional reduction means, guys, we are doing the feature extraction. So tell me, sir, what is a feature selection and what is the exact feature extraction? Okay, can you able to see now? So what is the feature selection is there, feature extraction is there. So what is a difference? What is the difference between the feature selection and feature extraction? Okay. Yes. Guys, 1 second. What exactly I'm trying to do here? So, for example, you can take. I don't have a good example to tell you here. Yeah. So feature selection and feature extraction means, okay. So ultimately we are going to do the in the purpose of feature selection as well as the purpose of feature extraction. So to reduce the dimensional reduction purpose, generally we will use this thing. Okay, maybe we will convert the 3-dimensional to 2 dimensions. Okay, the 100 dimension to 3 dimensional. Why? Because can you see, guys, visualizing the 1 dimensional is very easy. 2 dimensions also very easy. 3 dimensions also very easy. But other than 3 dimension, we cannot able to visualize the things, right? Okay, so we cannot able to visualize the things. So that is the thing, guys. We are using the something like okay, we are using the one second. Yeah, here what is the purpose of dimensional reduction means, can you see why we are doing the dimensional reduction means? Then one of the thing is to prevent curse of dimensionality. Second thing is improve the performance of the model, and third thing is visualize the data. Okay, understand the data. For example, so in the interview they might ask that what is the purpose of doing the dimensional reduction means. We can able to answer these three things. Okay, so preventing the curse of dimensionality. Okay, so improve the performance of the model and visualize the data, or we can able to understand the data. So for these 3 points you can able to answer in the the interview, guys. Okay, anyway, I will elaborate these things, guys. Choose the Monday. Okay, so I hope there is one point is missing in my case. That is something like a feature selection and feature extraction. Feature selection means, so unna vaatlallo select chesukovam. For example, I'm taking the, for example, you can take size of the house, number of rooms, okay, and for example location. These are very important features. So for example, if I add some unimportant feature, something like a number of people staying in the house, okay, which is not an important feature. So from that one I can take a specific important feature. So like we can take number of rooms, size of the house, location of the house. We won't take the number of people staying in the room. So that is a feature selection we can take. So feature extraction means, guys, for example, feature extraction means, guys, so we are combining the things, we are combining the two or more features, and we are extracting from something. For example, I'm having the size of the house, okay, and size of the house we can take any other example, guys. Size of the house and number of bedrooms, for example. Okay, number of bedrooms. Okay, or they can say size means, okay, fine, number of bedrooms, fine. From this thing, what exactly, so I'm having a separate size of the house is there and number of rooms are there. Okay, so is not exact size of the house we can take. What exactly we can take, guys, in this question? For example, size of the each room. Okay, for example, size of the each room and the number of rooms are there. So if you manaki emundandi, I'm having a one feature, the size of the each room and number of rooms are there. So these are like a looking like a two different features. But what exactly we can do, and we can combine this complete the size of the number of rooms and a number of rooms in the particular house. We can combine this like a completely like a size of the house. Ante kadandi, size of the house means we are combining the size of the each room plus number of rooms. So we're combining these two columns and making as a size of the house simply. So that is exactly like a extracting of the feature extraction. Okay, so some similar features are there, very similar features. We will combine both these things and we are making into one dimensional. Okay, so that is exactly called the feature extraction. మీకు అర్థమైందా అండి? What is the difference between the feature selection and feature extraction అంటే? అర్థమైందా అండి?
Yes, sir.
Very easy. సో ఫర్ ఎగ్జాంపుల్ సైజ్ ఆఫ్ ది ఈచ్ రూమ్ ఉంది, నెంబర్ ఆఫ్ రూమ్స్ ఉన్నాయి, మనం కంబైన్ చేయొచ్చు వీటిని, చేయొచ్చు కదండి. సో ఐఎమ్ మేకింగ్ ఎ సైజ్ ఆఫ్ ది హౌస్. So that will be a one dimension I can take. So that is exactly called feature extraction. So feature selection means from the existing features we are selecting the much important features. Feature extraction means, so in the existing feature we are combining the one or more, two or more features and making into one feature. That is exactly called the feature extraction. Okay, I hope you got it. Yeah. So we know with respect to feature selection, we know the techniques, guys. So for example, feature selection, which for the feature selection, so in the previous class also we have discussed like a covariance and a correlation for so formulas and theory also. For example, input feature is there, output feature is there. So from that we know that we can able to take two kinds of relationship. One thing is like a positive relation and something like a negative relation. Okay, so when x is increasing, y is increasing, x is decreasing, y is decreasing, that is something like a positive relation. And so one more case is like x is decreasing, y is increasing, and x is increasing, y is decreasing. So this is like a negative correlation. So you can take the visualize the graph also. So this is the like our positive relation. So when x is increasing means y is also increasing. So this graph is for the negative relationship. When x is increasing means y is decreasing. Okay, we have seen this thing. Okay, we have seen this kind of thing in the previous class. So positive relation and negative relation. So there's something like means there is something like a zero relation, guys. Okay, no relation means between the x and y means, so that is something like a forming in the circular form. So చూడండి ఇలా ఒకే దగ్గర in a circular form accumulate అయిపోతే we cannot say what kind of relationship it is. Okay, so there is no relationship between the x and y, correct? So that is the understanding. Okay, we can able to see mathematically also. So covariance of the x comma y is what? Summation I to n. We have understood this thing. So xi minus x bar into y minus y bar by n minus 1. So when we are getting the positive mean, like when we are getting this particular value, positive value means that is like a positive correlation covariance we can say, and negative means negative relation. So if we are getting approximately equal to 0 means there is no relationship between the x and y. Okay, so that is a we have understood very clearly in the previous class only. And the PSN correlation, we can able to see covariance of the x comma y. So sigma x of y and sigma y. So the more the ranging between the so minus 1 to and 1. So what is the range between, what is the range of covariance, guys? Range ఏంటండి? For the covariance, what is the range?
-1 to 1, sir.
For the Pearson correlation, what is the range of Pearson correlation and what is the range of covariance? What is the range of covariance, we can say? చెప్పండి.
-1 to +1, sir.
-1 to 1 దేనికి?
Pearson
కోవేరియన్స్.
correlation, sir.
ఓకే, మరి దీనికి కోవేరియన్స్ కి ఏంటి మరి? నేను మర్చిపోతున్నానండి.
Sir, the covariance is 0, sir.
సారీ,
Sir, the range is 0, sir.
రేంజ్ జీరోనా? డోంట్ ఆన్సర్ లైక్ ఇన్ ది ఇంటర్వ్యూ. ఆన్సర్ ఇట్ చేయకండి, ఆన్సర్ ఇంటర్వ్యూలో చదవట్లేదండి. ఇది -∞ to +∞ కదండి. సో ఓకే, సో యు ఆర్ నాట్ చదవట్లేదు సరిగ్గా. ఓకే, సో మోర్ ఐ మీన్ కెన్ యూ సీ నౌ? సో మోర్ పాజిటివ్ వాల్యూ మోర్ అంటే ఫ్రమ్ దిస్ విత్ రెస్పెక్ట్ టు ద కోరిలేషన్, పియర్సన్ కోరిలేషన్. సో మనకి ఎక్కువ, సో మోర్ టువర్డ్స్ ద పాజిటివ్ వాల్యూ మీన్స్ మోర్ కోరిలేషన్. దట్ ఈస్ ద అండర్స్టాండింగ్. ఓకే, సో వీఆర్ యూజింగ్ సేమ్ టెక్నిక్స్. ఓకే, సో మనం సేమ్ టెక్నిక్స్ యూజ్ చేసుకొని మనం వాట్ ఎగ్జాక్ట్ వీఆర్ ట్రైంగ్ టు ఫైండ్ అవుట్ ఈస్ సో ద రిలేషన్షిప్ బిట్వీన్ ద So what is that each feature? Okay, you can take so data of housing is there. This is the data set of housing is there. So size of the house, okay, fountain size, okay, and price is there. So from this thing, what exactly we can do, guys? The feature selection, size of the house is very important, okay. But fountain, having the fountain in front of the, so in front of the house, we can say I believe it is not important to, okay, for the price, okay. So fountain size, you can say saying that, okay. So we can able to drop this feature and we can take only what exactly. So house size, so size of the house. So for example, size of the house increase outunte, price also increase outunte. Okay, it is having the linear relationship and having the covariance is positive correlation. Okay, and something we can take one more understanding: fountain size and the price. Can you see, guys? Fountain size increase outunte, my price increase outuntara. Okay, not exactly. Okay, antaga increase outunte. So you can see there is a distribution is very local. So we cannot say. So the distribution is very low here. So maybe the range value, we can able to say the correlation value may be approximately equal to 0. Okay, sorry, covariance value may be approximately equal to 0. Okay, there is no relationship between these things. So that is the understanding of this thing, guys. Okay, so this is a simple example. The example and previous one, okay, example this same thing. So we are taking the one more example for this thing. Okay, so now feature extraction. So this I told you like okay, feature extraction again. So size of the room and the number of rooms in it. Okay, now we need to find out the price of the house. Okay, now we need to find out the price of the house. So now what exactly we are doing is, so in the we have to deduct the dimensionality, means two features I need to convert into one feature. Okay, that is like a dimensional reduction, right? So two features I'm making it one feature, that is exactly feature extraction we can take. So size of the room in the, and I'm having a number of rooms. I can able to combine the size of the room size and the number of rooms. So complete house size of the house. Okay, so completely size of the house. So I'm making these two features into one feature. So and I'm reducing the dimensionality into two features to one feature. So okay, how can we do this? How can we transfer? How can we able to extract into one feature means like it? So we are doing the transformation to extract the new feature. So we are applying some transformations, guys, to reduce the dimension of these features we can take. That means if you want to convert these two features into one feature, we are doing some transformation to extract the new feature. That means from these two features, we are extracting a new feature. That is the size of the house. So from the size of the house, I can able to predict the price. That is a simple understanding of these things. Okay. Now you discuss something like about dimensional reduction kind of thing. So now what are the techniques will help us to do these things, guys? Okay, manaki techniques emunnai ikkada. Okay. So first thing is what is like a PCA. Okay, principal component analysis. Okay, principal component analysis. So geometric intuition. Okay, మీకు చెప్పింది అర్థమవుతుందా క్లియర్గా? చెప్పేది పూర్తిగా అర్థమవుతుందా?
Yes, sir.
Yes, sir.
Any doubts are there to this point? No doubts, right?
Yes, sir. No, sir. No doubt.
Right. So now what exactly we are trying to do, guys? So we are taking the one technique, one algorithm we can take, that is a PCA, principal component analysis geometric intuition we are going to do. So what is, and again, what is the purpose of this PCA means? Again, for the dimension reduction purpose only. Okay. So for example, it's a very huge maths is there. I will try to cover up to some points only. Okay. Please bear with me, guys. కొంచెం ఓపికతో ఉండండి. We will see. Now, yeah, what exactly we are doing in the PCA? What exactly we are doing in the PCA? So, for example, housing data set is there. So, size of the house, number of rooms, and price is there. So, I told you we can able to extract with the help of PCA. We can convert this two dimension to one dimension. That is exactly feature extraction we are doing, right? So, size of the house and number of rooms are there. We can make it to one feature. That is the thing. Now, how exactly we are trying? So how exactly we are trying to do this thing? ఎలా చేస్తున్నాం సార్? You are saying sir, you are saying that we are making the 2-dimensional to 1-dimensional. Okay, so how exactly we are doing in the PCA part? So let us take, guys, so first let us take, I'm having the coordinates, size of the house, and so number of rooms. That means what exactly I'm trying to do, I'm making the complete, okay, I'm making the uh, 1 second. Yeah, so can you see I'm taking the two coordinates, so size of the house and so number of rooms, size of the house, number of rooms. Let us plot the scatter plot for this thing. Okay, I'm taking the two features. Okay, two features తీసుకున్నాం. So when we are taking the two features, okay, more than one feature means there is like a we can do the scatter plot. So the scatter plot is looking like this. Okay, I'm having these dots. Okay, I'm having this kind of dots. So yeah, now how we are making this okay, so size is there, size of the house and number of rooms are there, right? So two features are there. Now how we are exactly converting these two features into one feature or a 1-dimensional? Okay, so simply we can do, guys, I'm projecting these points into in the x-axis, so in the size feature, like a size coordinate. Okay, so can you see when it project just I will get everything will be in the only one line, okay, and the size line. So that is the reason. So we are making the initially it is 2-dimensional, but when we projecting into, so on the size line, a size coordinate, so we are making into like a 1-dimensional. Okay, so 1-dimensional. So what exactly we are saying is this, the distribution, this kind of distribution we can able to say that. So we can say this is like a spread of the our spread or variance of the our data. Okay, అంతే కదండి, ఇదంతా ఏంటండి our this is like a something like a spread of the data. So we can able to say this thing. Okay, so how the, I mean, when we are projecting that points into the our size coordinate, so we are seeing that this is the distribution of the data. Okay, so but the problem is can you see now, the problem is we are neglecting the complete number of rooms information, correct? We are focusing on the spread of the like a size only. Okay, but we are neglecting the, so what is that importance of the number of rooms, correct? So that is the point we can able to. Can you see now in between this thing we are projecting this line, for example, not exactly neglecting directly, guys. Can you see? So in the simple term the loss of information is there. Okay, can you see from this point to 1 second, from this point to up to we are projecting to what exactly this is like a spread we can able to see now. Okay, so completely we are, what is the spread is there with respect to number of rooms, we are neglecting that thing. Okay, there is a loss of information is there. Okay, while extracting that feature, so we are losing some information, correct? So how to overcome this problem? ఇప్పుడు ఎలా చేయొచ్చండి? ఇప్పుడు చూసారండి ఎంత మనకి ఎంత ఇన్ఫర్మేషన్ లాస్ అయిపోయింది, ఆల్మోస్ట్ జీరో. We are neglecting the spread of the our number of rooms. Okay, almost like a zero. So how to overcome this problem? So to overcome this problem we are going to do something like a simple, okay, let us try to apply the common sense first of all, and after that one we will see so what is the maths behind this thing. So see, guys, ఇప్పుడు ఏం చేస్తామనంటే, so I'm trying to apply some principal components. Here. What exactly principal components means? Initially these are coordinates I'm having, size and number of rooms are there, so these are distribution of data. Now I'm shifting the size to the in this direction. These are size of the my house. Okay, it's like a size and it's like a size dash. Okay, this is like a principal, this line is something like a principal component 1. Okay, so size మీకు transform అయింది కాబట్టి in the same the 90 degrees our number of rooms will be okay transformed. Okay, can you see this is the number of rooms. Now what exactly we are trying to do, Andy? So now what is the same thing we have done? We are having a two features. We are going to convert those two features to one feature. That means for that one I am projecting that point into my coordinate. Okay, my coordinate. Can you see my size dash coordinate? Now we can able to, there is no much loss of information is there. Can you able to see, guys? There is no much loss of information compared with above thing. So above value, So there is no much loss of information is there. Okay, still we can able to, so what is that, consider the so number of rooms information also. Okay, so that is understanding with this thing. Okay, okay guys, no issue. It may confuse you if itla cheppunte confuse avachchu meeru. So and also I need a complete 1 hour class to discuss everything, all these things. So tomorrow I will be discussing these things, okay, what exactly this match intuition between the PCA, okay, principal component analysis, and what is the importance of the eigenvalues and eigenvectors involved in the PCA. We will be discussing in the tomorrow's class. Sorry. Okay.